Let's talk about soil water. Soil water is quite a complicated topic, and it's due to a couple of reasons why that is the case. Um, the first one is there's very many things that can happen to water as soon as it falls on the soil surface. So, for example, it can run off right as it hits the soil surface and go someplace else, or it can infiltrate into the soil and then migrate down the soil profile and eventually also become groundwater and sort of everything in between. So there's quite a bit of fates available for any droplet of water that falls down. And the second reason why soil water is such a complicated topic is that there's so many forces acting on soil water. And well, there is of course gravity. So water typically, but not always, moves downward, down the soil profile, following gravity. But there's also other forces that act on soil water that make this such a complicated topic. And one of them is there are usually things dissolved in the soil water. So soil water is typically much more concentrated than let's say a cup of water that sits on your tabletop. And so therefore there is a lot less energy available for that water, a lot less degrees of freedom, let's say, for every molecule in the soil water compared to that glass of water on your table, which means in soil physics speak, the potential of water gets more and more negative the more things you have dissolved in water, which means basically things are going to pull on that soil water. And that's a real pull that's experienced by organisms. Then you can also measure it with a tensiometer, like a pressure indicator. And the second important force is the surface that acts on the water. And soil is basically phenomenal because it's essentially just a massive internal surface, and water that interacts with all these surfaces then is also not available to do other work, so it further lowers the water potential. And so what that means is that water is more difficult to get by organisms, including plant roots, but also bacteria and fungi. So there's all these forces acting on soil water, and that makes it very complicated a topic. But at the same time, it is a very important topic, of course, because soil water is what enables life in the soil, and without life, there is, of course, no soil. And of course, it's very important to understand how soil water behaves if you want to understand how water moves into plants, for example. And so that's a very interesting topic because plants basically plug themselves in between the super very negative water potential of the air and the negative water potential in the soil. They're sort of right in between, and so water moves through them. And that is also the driving force how they get, for example, most of the nutrients into these plants. Yeah, so soil water is a super important topic in ecosystems and also in soil, and also for anything to do with plants. And so it's interesting to think about the complexity of soil water as you walk around after a rain, as I'm doing just now. And with that, see you later.